Okay, good morning. This is Professor David De Los Reyes. Okay, my topic for this morning will be, I go a little bit, my head is too high. My topic for this morning will be radical expressions. Okay, this is the topic that in the short video on YouTube always come out. Okay, radical expressions. It's the study of fractional exponents. Okay, let's proceed. The topic for this morning will be a long video format discussion, and this is college algebra, and this is now lesson number 26. We are running smooth on college algebra. Okay. The title of the topic will be radical expressions. Okay. Let's continue. But before we continue with the explanation of the legend, we'll try to define first what is a radical expression. Radical expression is an expression that contains a radical sign. So any expression that contains a radical sign is considered to be a radical expression. Okay, let's try to bring out the legend. This is the symbol for radical sign, this one. Okay. We got a radical sign and we place a number A inside. The real number inside is the so-called radicand. Okay. So we got a radical sign and we got a real number inside. And on this portion here, we got a designation small letter n, and we call this small letter n as the so-called index number, or just simply index. So for under the discussion of radical expressions, okay, just memorize three terms under legend, right? The symbol for the radical sign. The number inside the radical is the so-called radicand, and the number or the exponent of the radicand is termed to as index. Okay? I will try to bring out a note over here. If the value of n is equal to 2, the index is actually omitted. Okay? Meaning to say, if we got a radical sign here, and there is no number here, okay, it is understood that the value of n is equal to 2. Instead of placing 2 here, okay, the standard notation is that if there is no number here, it is considered to be a square root. But if there is a number 3 over here, of course, you will not call that one as a square root. It will be cube root, right? But I've been hearing some discussions on short videos. I'm not criticizing other YouTubers, right? I've heard that there is a 3 over here, and she says that it is a square root. So that's actually an incorrect thing, right? So if the number here is missing, it is considered that the index is actually equal to 2, meaning it is a square root. But if this is 3, that's cube root. Okay? If this is 4, that will be 4th root. Okay? But if there is nothing here, I will repeat it for the last time, it is a square root. So under the study of radical expressions, okay, at least we now know what is a radical sign. This is the radical sign. The number inside the radical sign is the so-called radicand. And the exponent of the radical is actually the so-called index. Right? And regarding the note, if n is equal to 2, actually we do not place 2 over here. Okay? You can please do if you want, but it is a standard in the study of algebra. But if the number here is missing, it is understood to be a square root. Okay? And at least we now know what is a radical expression, right? An expression that contains a radical sign. So if a given expression got a radical sign, that is to be considered a radical expression. Okay, let's try to bring out the formulas that contains rational exponents. Rational meaning this is fractional. Fraction. The exponent is a fraction. Okay. That is an a raised to 1 over n can be written as the, okay, this is the radical side, this is the radicand, and the index is 2. So these two here are actually equal. If we try to read this one, the nth root of a, okay, if we try to read this one, that is the nth root of a. So a raised to 1 over n is just equal to this square root sign here, or this radical sign here with the number a inside, and the power or the index here is actually n, right? Next one, a raised to the ratio m over n. Okay, rational exponent, fraction, right? Can be written as a raised to, this is one variation, a raised to 1 over n, again raised to the m power. Okay, this is with the quantity, right? So meaning to say a raised to m over n can be written as a raised to 1 over n, raise that again to the m power. Okay, that's the first equivalent. The other equivalent will be this one, a raised to mn. This can be written as a raised to m. Okay, raise that again to 1 over n. Because actually 1 over n times m is actually m over n mn, right? So on the first one, we could do that to be 1 over n. This is with the raised to m. That's this, right? But we could place this m here inside. Okay? And we place the 1 over n outside. Anyway, the operation is multiplication, right? Because the product 1 over n times n is actually m over n. So this one here can be written as m times 1 over n. So the next equivalent of e raised to m over n, this can now be written as e raised to m times 1 over n. Anyway, the operation is multiplication, right? Because m times 1 over n is actually m over n, right? And 1 over n times m is still m over n. And if we try to place the equivalent of this one with the radical sign, it should be this is the radical sign, this is the m root of n. Okay, we read this one e to the m, the nth root, right? So these three here are actually equivalent. Okay. This is e to the m, the nth root. Okay. So don't forget these three rational exponent formulas. Okay. I think these are the solutions of the short videos coming out on YouTube, right? And we've been saturated with this one because the solutions that are being brought out is the solution by using the laws of exponents under the radical expression. Okay, let's try to bring out an example. Simplify, okay, the given quantity is 27. I will just give a pure number here. There will be no x or no y, just pure numbers. So the concentration of the subject matter for the meantime is the simplification of radical numbers, right? So 27, or simplify, 27 raised to 4/3. I think this has similarity to one of the problems under the short videos, okay, that is coming out. Okay, let's try to bring out the solution. 27 can be written as the possible prime factors of 27 will be a 3 times 3 times 3, right? And if we try to simplify 3 times 3 times 3, this will be 3 raised to the third power. Or multiplied by itself 3 times. Or in terms of exponent, this will be 3 raised to the third power. So 27 raised to the 4 thirds, this should now be equal to. From this, instead of writing 27, we will write the value of the radicand inside the radicand, to be 3 to the third power, raise that again to 4 thirds, right? And this one here should fall under the product mn, okay? Where m is actually 3 and the value of n is actually 4 thirds. And luckily, these 3 here cancel this. So what comes out is just 3 raised to the 4th power. And the answer is actually 81. If you want to check the validity of the answer by using the simplification using radicand, actually you could use your calculator. Okay? Just display 27. 4 thirds is 1.333. So this should be y to the x 1.3333, right? A recurring number, right? And the answer should be 80.999, or that is approximately 81. So the correctness of our answer by using the calculator, the answer here is 81. And as per solution regarding the radical solution method, the answer is actually 81. That is by replacing 27 by 3 times 3 times 3. Then we put it inside. Then we try to simplify by using this rule here. Okay? Because these 3 here cancel with this. So what will come out will be 3 to the 4th. And 3 multiplied by itself 3 times is actually 81. And you could check the validity of that one by using the calculator. Okay, list example for this morning. This first part is an easy one, but the next discussion is still under radical discussion. It will be another topic, okay? Our last example for this morning. Simplify the given radical expression is 600. The ratio 625 over 81 raised to 5 halves. Okay. So what do? We try to take the prime factors first of 625. 625 is actually a perfect square. That is 25 square. So it will be 25 times 25. And 25, it's still a perfect square. It will be 5 times 5, and 5 times 5, or this should be 5 raised to the 4th power. Meaning to say 625 is actually 5 raised to the 4th power. And for 81, the possible prime factors initially is 9 times 9. In 9, it got still a prime factor, which is a 3 times 3, 3 times 3. Or this will be 3 to the 4th. Okay, so if we try to go back to the ratio 625 over 81 raised to 5 halves, this should now be equal to, I just rewrite this one, then I place the equivalent of this from this, right? So instead of writing 625, I wrote it as simply 5 to the 4th, raise that again to 5 halves, all over 3 to the 4th, raise that again to the 5 halves. So actually we use, this will be a division, but I think this is the next topic. But anyway, this is a simplification of radical. So what I did is that the ratio A over B raised to n, this can be written, or simply 1 over n, should be A raised to 1 over n over B raised to 1 over n. Okay, how we could do that? So this should be pi to the fourth raised to 5 halves over 3 to the fourth, again raised to 5 halves. And on this portion here, we use this, right? So 4 times 5 halves, right? It should be product. You should not add. It should be multiplication. So these two here cancel with this. So what comes out will be 2 times 5. The simplification of this will be 10. So 4 times 5 halves will be 10. So this is now 10. Right? Even the bottom portion, it will be 10. Or since this is 10 and this is 10, we will just take this ratio here under one common exponent 10. Okay? If we try to check the correctness of our answer, how we could do this? We will divide 625 divided by 81. So this is a decimal number 7.7 something. And 5 over 2 is actually 2.5. This is y to the x 2.5 equals. This is the value of this is 165.38. If we go directly to these numbers here using our calculator, and to check the correctness of our answer is actually 5/3 raised to the 10th power. So you just take 5 divided by 3, okay, raise that to the 10th power. This is still 165.38. So the equivalent of this is actually 165.38, and this one here is same as this one. So our answer, 5 over 3 raised to the 10th power is correct. Okay, that's it guys. That's the way how to simplify radical expressions. Okay? At least we now know what is a radical sign. This is a radical sign. At least we now know what is a radicand. Radicand is actually the number inside the radical sign. At least we now know what is an index. Index is actually the exponent. Okay, n. We call that index. And there is a standard rule. If the value of n is equal to 2, like this one, we read this one to be square root. Okay, this is not cube root. Okay, for it to be cube root, this should be 3. Okay, but if the number is missing, it's understood to be square root. That is standard. So if you see a radical sign under the study of algebra, it is understood to be square root. Okay, but if there is a number there to be 3, that's cube root. If it's 4, that's fourth root. If it's 5, that's fifth root. Okay, and the equations on how to simplify what you call this radical expressions, use these 3 formulas over here. That is a raised to 1 over n. This should be equal to this value here, the square root of a raised to n, right? And a raised to mn, this can be written as a raised to 1 over n, raise that again to the n power. Or this one, we could interchange the location of m and 1 over n. So as a second choice for the equivalent, this one can be written as e to the m, raise that again to 1 over n, or this should be equal to this is square root thing over here, e to the m raised to n. Okay? Okay, that's it guys. So for those of you who are taking or studying college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. Okay, try to watch my long video format under my channel. You will learn something from it. Okay, good morning from Los Angeles, Professor David J.